What are we doing today?
If you go to that website we were on, yeah, that one. We're
Okay.
doing 12.3 and 12.4.
Okay. Open other. Okay. What is the, if we knew the measurement of this angle right here, we would know that this arc is what relationship to this angle? This angle defined by this chord and the diameter line.
Equal?
It's only equal if it's like this. If it's coming from the center. In other words, if that's 70 degrees, then that's 70 degrees. But if it's coming from the bottom or somewhere on the circumference of the circle, if this is 70, this is half that. This is 35.
Okay, so it
Okay.
would be
So what is the measurement of this tiny little angle right here?
half of 38, so
19. And then what is the measurement anytime a tangent line always forms a 90-degree angle with the radius at that point? So we know this is 90, and that's 19, so it's got to be 109, yeah. Let me make this a little smaller here. Given that DAB is a right angle and M measurement of ACD is 310, what is the measurement of ADB? Okay, let me draw that triangle, ADB. Okay, they've told us that that's a right angle because whenever you inscribe a triangle into a semicircle, it makes a right angle.
right.
In other words, if I put a triangle into a half of a circle, it always makes a right angle no matter where I put it. This is a right angle. That's a right angle.
All right.
Okay, and that's a good thing to remember. That's a critical thing. So they've given us the measurement of ACD, it's odd that they call it ACD. I guess that's from this point all the way around to this point. So therefore, what is the measurement of this arc AD?
Wouldn't it just be 50 then?
Okay, so if I draw that arc, that's 50 degrees, making this angle be what?
25, because it'd be half, right?
Okay, and then what is ADB, which is what they're asking about?
You'd subtract 75 from 360, right? would it be from 180?
Always remember that when you're dealing with right triangles, the two small acute angles are complementary. They add to 90, so this has to be 65. This and this have to add to 90 whenever you have a right triangle.
Okay.
So that's 65. Find the measurement of angle BAC. So what arc measurement are we going to need to find the angle BAC?
The arc measurement of A to B?
Of B to C.
B to C.
Notice that these two chords intercept this arc BC. So we know that this angle A is going to be half of whatever this arc is.
Wouldn't that just be 60 then?
Yes. So what is this angle BAC equal to?
Oh, BAC is 90.
No, BAC is this angle right here.
Oh, okay. I'm sorry. I was looking at that wrong.
Okay. Which statement is not true? Okay, let's examine every statement. Let me turn my camera off. I'm getting messages that I'm overloading my computer. Well, right off the get-go, we can tell that both B and C cannot both be true.
Right.
Notice that B and C have to be supplementary.
Right.
And they've got them adding to 181 degrees. So we know it's B or C that's wrong, since they cannot both be true. So I'm not even going to examine A. I'm going to look at B and C. Well, what do we know about B?
It's bigger than 90.
It's also equal to which arc? From here to here. Correct?
Right.
Okay, well that's the same arc that's intercepted by this 51-degree angle. So what is that arc measurement?
51 degrees.
No. Remember that it's only equal if it comes from the center of the circle. If it comes from the circumference of the circle.
Half of that.
Okay, so what is this arc?
It is 25 and a half.
Does it look 25 and a half?
No.
Okay, so you're going the wrong way. In other words, you got the 1/2 is correct, but this angle is 1/2 the arc. So what's the arc length?
1/2 the arc.
This 51-degree angle, here's our situation. We have a circle. We have a 51-degree angle that intercepts this arc. We'll call it AB. And if this angle is 51 degrees, what does this AB arc have to be?
Oh, they'd have to double it, wouldn't it?
Right.
Okay, so it would be 102.
So this is a 102-degree arc, but angle B does have to equal that arc because it intercepts exactly the same arc. So there's no way angle B can be 103. It's got to be 102.
Okay.
Okay, if arc BY equals 38, what is the measurement of YAC?
B to Y is 38, Y to A. So it would be 18, or I'm sorry, 19.
Would be which angle?
Angle Y to A would be 19.
Describe the angle with 3 letters. 2 letters don't describe an angle.
All right.
Y to A does not describe an angle. YAO or YAB describes this angle right here.
All right. YAB would have to be 19, wouldn't it?
Correct. And BAC is what?
B to A, 90 degrees.
Okay, so what is YAC?
You'd subtract 19 from 90, right?
Uh-huh.
71.
For some reason it won't take that. There we go. All right, let's see how we did here. Okay. You said 12.4 also?
Yeah.
I'm going to have to pull out my book.
All right.
There's a formula for this, and I don't do it enough to memorize it. Circles. Where are circles in my book? Hold on. Chapter 10. Tangents to circles. All right. Well, let's see. Okay, which situation do we have here? We have, wow. All right. Now let's see here. This 56 is the measurement of this chord. Is that correct?
I think so, yeah.
Okay. Second. All right. Here's the general theorem. If you have a tangent and you have a chord, EA squared is equal to EC times ED. And the corollary to that would be this situation where you have this going on, where you have EACD, we'll put a B in here. The primary theorem is that, looking at this bottom drawing, is that EB times BA equals EC times CD. In other words, you have two chords intersecting outside of a circle. So the segments of each chord, the product of those segments, is the same as the product of these segments. Now, notice that this situation up here, it's EA times EA is equal to EC times CD. Well, that makes sense. I mean, assume that if EA wasn't tangent, but it was just barely not tangent, like that. Well, according to the bottom picture, we know that this times this is equal to this times this. Well, if we change EA to just... I
can't see your cursor at all.
You can't see what?
Your cursor, so when you're saying this time, this, I can't see that.
Oh, I bet it's because I'm using the pen. Can you see my cursor now?
No, not really. It's just,
yeah, it's just a little red dot. Okay, well, I'll try to define everything by letters. So the two situations are where you have the two chords intersecting outside the circle, and the other situation is where you have a tangent line intersecting a chord. And think of the tangent line as being EA times this other segment, which is just EA again. So it would be EA squared equals EC times CD. And that's the situation we have here. So, hold on. We know that, what's the equation I can write?
I'm not sure.
Okay, let's go back and look at what I drew. In this situation here, this equation that I've written applies. EA squared equals EC times excuse me, I wrote it wrong, equals EC times CD. In other words, this squared equals EC times CD. So what equation would apply for this example or problem number 1?
7 squared.
No. It's the tangent line that's squared.
Oh, so it's x squared equals, and then 7, it would be 7 times 56.
Correct. I'll let you solve. Well, do you have a calculator?
Yeah, I do. I'll enter it in real quick.
What's the square root of 7 times 56? Let me see if I can guess. That's about 400. It's going to be 20 something. It's either going to be 21 or 22. Let's see, this ends in 2, so what number multiplied will end in 2? I don't know.
That doesn't make sense, because when you do 7 times 56, you get 392, and then when you square root it, you get 19.79.
Boy, you sure do. Ah, I got my formula wrong. I was writing it from the book, and I was right the first time. It's EC times ED. Now that makes far more sense to me now that I think about it. In other words, I explained it to you wrong. EA times EA is equal to EC times ED. So in our case, it's x squared equals 7 times 7 plus 56, 63.
Okay.
Do 7 times 63.
Square rooting that, it comes to 21.
Okay, so that's the answer. Yeah, I'm glad I saw that. I wrote it wrong, and then I thought I had written it correctly, or incorrectly, and I changed it. So anyway, so let's review that again. EA squared equals, that's the tangent line, and it's not equal to the product of these two segments. It's equal to the segment length that's outside the circle times the full segment length. In other words, EC times ED.
Okay.
Okay? All right, let's go back and do more here. A footbridge is in the shape of an arc of a circle. Okay, so if I try to draw that, there's the footbridge. And it is 7 feet tall, so that measurement is 7, and 28 feet wide. So this is 28. What is the radius of the circle that contains the bridge? In other words, if I extend the bridge further all the way down so that there's a center of a circle here, what's the radius of that circle? And this also has special formulas. Let me turn to those. Let's see, in my book. It's really out of order from yours. I'm thinking.
All right.
So we want this measurement. Okay. Finding the center of a circle. Just a second. Why is this so hard? Just a second. I see a problem here that's very similar. Let's see. I'm not sure I know how to do this one.
They didn't have this in our lecture yesterday.
Well, I think this has to do with, just one moment. Maybe I can find it in my book. I don't think so. Yeah, let's skip over it for the moment. No, hold on. I think I got it. If two chords intersect in the interior of a circle, then the product of the lengths of their segments of one chord is equal to the product of the lengths of the segments of the second chord. EA times EB equals EC times ED. In other words, if we draw the complete circle and we connect those chords, then what this theorem says is that this times this is equal to that times that.
All right, so 3.5 times 3.5 is 28 times
Well, it's not 3.5. The 28th is the length of the bridge. And if we assume that it's 14 times 14, then we could say 14 times 14 is equal to 7 times the length of this chord, which would have to be 28. However, which means the length of the diameter is 35, which means the radius is 17 and a half. All right, let me go through that again. I just discovered it myself. Okay, they said the height of the bridge was 7 feet. So it's 7 feet from there to there, right?
Right.
They said the length of the bridge was 28. So each of these segments has to be 14.
Right.
Okay, so if each of those segments, let's erase everything we don't know here, and this full thing is a diameter. From here to here is the diameter of the circle.
Right.
Okay, so let's let this full distance from here to here be x. So I can say 7 times x equals 14 times 14. Well, clearly x is 28.
Okay.
And if x is 28, that makes the full diameter of the circle 28 plus 7, which is 35. The radius is what they asked for, which is going to be half the diameter. 17.5. All right. Compare the quantity in column A with the quantity in column B. Okay. Again, let's see. AX. Wow. Which is bigger, AP or AX? Well, let's see. What do we know? We know that AP is equal to PQ times PZ.
So you're doing 6 times 4?
I haven't gotten around to doing anything yet, but yeah, it looks like that's what we are looking at here.
Alright, so AP...
So AP squared, AP squared is equal to PQ times PZ. PQ is 4. What's PZ? Is that 4 plus 3 plus 6?
Yeah, so 9...
So AP squared is equal to 52. And we also know that, there's a much easier way to figure this out. Okay, so we got AP. Now, AX. What we just found out about chord segments is that ZX times XQ has to equal YX times XA.
All right.
Okay, so we've got ZX, which is 6, times XQ, which is 3, has to equal XY, which is 2, times AX. So AX is equal to 9. So which is bigger?
AP.
AP is the square root of 52, which is 7 and change.
Oh, okay, I'm sorry. I thought when you did AP squared it would do the same to 52 squared, so it'd be AX.
Right, AX is bigger. Column B. All right. Find the measure of each variable if angle A is 22 degrees and angle or arc BC is 97 degrees. Find the measure of X and Y. All right, so what do we know here?
B to C is 97.
Yeah, we got a lot of, I got to look up these theorems on angles, and that's at the beginning of this chapter. Okay, we got it, the page. So, angle A, according to the theorem, is equal to 1/2 of the difference in the arcs. So it would be 1/2 of CB minus measurement of B, this angle right here, which is X. So I'll just label that X. Okay, and if angle A is 22 degrees, then it's equal to 1/2 the measurement of BC, which they've given us as 97, from here to here, obviously not drawn to scale because it looks closer to 180, but they're saying that that's 97. So that's the measurement of that minus the measurement of x. Well, we can solve for x based on that. So we get 44 equals 97 minus x. Move x to the other side, 44 to the right, and I get 53 for the measurement of x. And then the measurement of y. The measurement of y has got to be well, it's certainly not 210, so it's got to be 105.
How do you know it's not 210?
Just by looking at it. In other words, they haven't drawn it to scale. It's less than 100. It's less than 90 degrees the way they've drawn it.
Okay, so.
Yeah, there is a formula for it. Let me think if I can figure out how to solve for y. Let's see, if I have a tangent line intersecting a chord, measurement of that angle is the same as this arc. It's not the same, it's half. In other words, that tangent line and this chord intercept an arc from here to here.
All right.
Okay. And it's half of that arc. Well, we just solved. They gave us CB as 97. We just solved X for 53. That makes 150. That means this arc from here to here is 210. That means that angle is half of that arc. So it's definitely 105.
All right.
In other words, here's the thing you need to know, that if I have a circle and a tangent line and a chord, the distance from here to here around the arc is half of this angle. For the same reason that two chords intercept an arc twice as long as this angle. In other words, if this angle is A, this arc is 2A. Well, notice that if one side of this arc becomes a tangent line, watch what happens as I make it closer and closer. Okay, angle A still intercepts the arc 2A. And then I'm going to make that closer and closer. I'm going to make it a tangent line like that. Well, this angle A still intercepts the arc that's 2A from here to here. And I can figure that out as being 210 is the length of that arc. Therefore, that angle has to be half of that, 105.
Okay.
All right. It's a hard one tonight. It's probably just because I don't get a whole lot of practice with these. This is the geometry stuff that you do not need for the ACT or the SAT. I will tell you that in advance. You do need it for your geometry class, but it's not geometry that you're expected to learn and memorize forever. All right, number 5 is relatively easy. Remember that number 5, we have a tangent line and we have a chord. So we have an equation that says CD squared is equal to C times B times A, C times A. So the equation I can write is CD squared equals CB times CA. You see why that's true? In other
Yeah.
words, you have a chord and you have a tangent line that intersect. That's one of your theorems. Okay, well, they've given us CD as 19, so this is 19 squared. What else have they given us? BC is 15. So that's equal to 15 times CA. So let's solve that. What's 19 squared? Something like 361 maybe?
Yeah.
That's equal to 15 times CA. So what's CA equal to?
Subtract. How would you do
Divide.
that then?
Divide by 15.
Oh, okay. So hold on. It'd be 24.06.
Okay. Notice that's the different distance from here to here. They want the diameter of the circle. So we need to subtract from that distance BC. They gave us BC as 15. So we're left with
9.1.
yeah, only it doesn't round up, but that's the closest thing. All right, let's take a look. See how we did here. Whew. You were a toughie today. I had to go through and retrieve all these formulas, but that's that. And those are the formulas you need to know. That we went over the formulas you need to know for this section. But they're kind of hard. They're not standard run-of-the-mill formulas that you memorize all the time.
Right. I'll have to review them later tonight. I always do that like right before we have a test. I'll wake up earlier in the morning and I'll just
That's a
watch
good
our
thing.
test.
You probably have 5 to 10 formulas involving tangents, chords, and stuff like that, and how they relate. And you need to memorize all of them. We didn't even go over all of them today. Okay.
Alrighty.
Good to go today?
Yep, that's all I got
All right.
today.
Well, we'll do a 3/4 hour session today.
Alrighty.
Okie dokes. I will,
Alrighty.
let's see, you're on for next Monday, correct?
Yep,
3:30?
and that's, I'll have more things to do Monday
Okay.
to figure stuff coming up.
Okay. I'll talk to you on Monday.
Alright, sounds good.
Bye-bye.
Alright, thank you.